So when people are like, I don't know him to pick. Yeah, and I'm like, they're like, didn't he get a
Okay, so what about this one? So what do we do here? We're gonna launch. If you want to draw a picture, you know, if you're artistically inclined, you can do that. Actually, that would be a bad picture. So we're launching this projectile at an angle of 75 degrees relative to the horizontal, so something like that.
I can't ever picture these.
Okay, and that's just our initial velocity vector, right? So it's going to arc up in the air and come back down and hit the plane below, the level plane below. So this is exactly like the other problems that we've done. The only difference, like we did one where we launched the projectile off horizontally, right? Only difference is this time that there are going to be both horizontal and vertical components to the initial velocity, whereas previously it was all horizontal, right? Mm-hmm. Okay? So all we have to do, just like all the other projectile motions we do, they're always the same, right? We're going to break the motion up into horizontal and vertical components, and we can separate the two and treat them independently, which is why this stuff, it looks like it'd be complicated, but it's not so bad. Think about it this way. Projectile motion is just the idea that you're going to throw something up in the air and catch it, riding piggyback on the constant horizontal velocity, right? So you just, instead of just this, it's like that, right?
Yeah.
And you're just going to separate those two things. Horizontally, it's dead simple. It's just constant velocity, horizontal motion. Vertically, it's identical to just throwing something straight up in the air and catching it, right? Okay, so let's do that. Let's break this up into components. So this is a 70, so here's our initial velocity vector. I've got to break it into components, right? So we're going to break it into, if that's v sub 0, we're going to break it into v naught sub x and v naught, and they're right angles, right? V naught sub y. Okay. What is v naught sub y going to be in terms of a trig function? If the magnitude of the velocity vector is 39.9, what do I always do to a vector to find a component of the vector?
Wait, what do you mean?
So if I want to find any some component of a vector, x, y component, parallel, perpendicular component, anything like that, I take the vector and multiply by either sine or cosine, right? Mm-hmm. And so it's always going to be a question of, is it sine or cosine? Well, in this case, the vertical, if this is the angle over here, is that the opposite or adjacent side? Opposite, so it's sine, isn't it?
Yeah.
So we get 39.9 sine 75.0 degrees, right? Okay, what about the x velocity? I could call this v naught sub x, but is the velocity ever going to change in the x direction? No, because that's one of the hallmarks of projectile motion, is that the horizontal component of velocity is constant, right? So we don't even really need the naught there, do we? We can just write this, if we want to simplify it, as v sub x. It's going to be the same the whole time. And that is what then? Times, yeah, cosine, right? Cosine 75.0 degrees, and that is a constant, okay? Good, so there's our initial velocity stuff. What is our initial position in the x direction? So x naught. What would we call it?
0.
0, sure, we're going to start from 0, aren't we? And really what we're trying to do is just find x, aren't we? X final?
Yeah.
Okay. So we've got to fill in that blank. In order to do that, what are we probably missing from the left column, do you suppose? Time, yeah. But where do we find time?
Why?
In the right column, because the time is really dictated by the vertical motion. The time ends when the rock hits the ground, which is because of the acceleration of gravity, right?
Yeah.
Okay, so what do we know here? What is our initial y position?
0.
Well, yeah, 54.1 probably, because that's the height of the cliff. And what's the final position? 0, okay. What's the acceleration? We know that.
Negative.
Negative 9.8, good. And then we're trying to find t, aren't we?
Mm-hmm.
So what's the equation we're gonna use to find t?
Big mama.
Big mama, that's right. So for this case, it would look like y equals y naught plus v naught sub y t plus 1/2 a sub y t squared, right?
Isn't this basically like the rest now, since we figured out the velocity?
It is, yeah, it's very much like all the other stuff we did. Really, that's the only difference, isn't it?
Mm-hmm.
So then, this is one that we're gonna solve, yeah, this is one we'd have to solve using technology, isn't it, right? So this is 0, and we'll just plug those numbers in and do this using polysmoke, right? So if we get, let's see, go into apps. Second order, everything looks like it's, oh, we want probably decimal, don't we? Otherwise, that looks good, right?
Wait, what?
0.71.
Okay, so what's the coefficient of t squared gonna be then? What's 1/2 times g? Yeah, negative 4.9. So negative 4.9. What's the coefficient of t is gonna be that, right?
Mm-hmm.
39.9 times sine 75.
Do you have to put the times, or can you just put the times?
Say it again?
Do you have to put the times, or can you just put the
Oh, you don't have to, I don't know on here. I wasn't sure on here if you don't normally, but that's why I put it, just in case. And then, let's see, the y naught was 54.1, I think, wasn't it?
Yeah.
Right?
It was.
54. Okay, and solve. Okay, we got 2 of them, which is the one we want, positive one. Okay, I don't know how, remember I tried and I failed to find a way to like just store that number somewhere. I don't know where I can, so I'm just gonna write the whole thing down and then we'll round it. But we might need it for later. What's that? Oh, I see, yeah, I wonder what that
You
is.
do alpha, yeah, do alpha and then do that. No, second, why you hit that, right?
I just hit that.
Click that,
Just
see what
click
that does.
What happens? Store coefficient, oh, you see, we tried this too, remember?
Oh, I don't know.
I think we did, I think we tried this.
No, but then can't you just
Yeah,
go
but you
through
can
the
do it
list?
this and then do list 1.
Yeah.
Okay, we'll try this, but I'm gonna quit and write this down first, and then we'll try this once, because this would be good to know. If it works, it'd be convenient for you to have this information, but I don't think it's gonna work. At least not how I know how to do it. Maybe you can figure it out. Okay, so now let's try this. So we go store coefficients to, oh no, we don't want coefficients.
2y equals, I don't know.
Store roots to list. Okay. Store,
Do list 1.
so I can just do second list 1. Enter. Okay, so now if I go to list, oops, that's not what I want.
You need to put second
Second
list, yeah.
foot.
There we go.
Quit the whole thing.
Quit it.
Yay!
Okay, but how do I, the thing is, how do I get that number out of there? That's still my problem.
Can you highlight one of them, or will it always have, oh no.
You
You
can
can
go
go
back
back,
and delete.
That takes you
Ooh, not
Delete
bad.
the whole thing.
Like
I
you
don't
have
know.
to click it and
I
delete.
mean, is there a way to edit lists?
There must be, but I just don't know how. Probably it's a subscript. You probably have to pick, I would think it would be L1 sub 1 sub 1 probably gets you to that element of the list, but I don't know. I'm not sure. Okay, so here's our number. So we're gonna round that, aren't we? The stone, oh, we never asked for that, are we? Okay, Lance, how far away? Well, that number times that, right?
Mhm.
Everybody agree?
Yep.
And that just comes from the equation, remember it used to be we called it D equals D naught plus V bar T.
Yeah.
So for us, that would look like X equals X naught plus V sub X T. And X naught is 0, so that gives us, what? That gives us, so I could cheat a little bit, couldn't I? No, that's too much. Okay, so we get 39.9 cosine 75 times that. And you know what I really should do is I should type that into my calculator and hit enter. How come?
Because then you'll have it.
Then I'll have it and go back up and grab it whenever I want to. Right. 9.088118612. Probably overkill, but there it is, 93.8 meters. Yeah, stone hits the ground with the speed of, okay, what about this one? This is one I think there were still some questions on. So we know the x component of the final velocity because it's the same as the x component of the original initial velocity, right? It doesn't change. But the y, we need the final v sub y, don't we? Okay, how am I gonna find that?
And I put 8 times time plus 39.9 plus times.
Yeah, you got it. So it's v sub y equals v naught sub y plus a sub y t, right? So we can plug that stuff in. That gives us,
Wait, what equation is that?
that's the
V
third,
equals V naught.
second one.
Okay.
So
Oh.
39.9 sine 75 plus negative 9.8 times that number, which I should have typed out. Okay, so we get a velocity of negative 50.45, blah, 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 right? Okay, so that means that if we were to draw these vectors, it's negative because it's going down. So I'm going to have this v sub x and this v sub y. And what I'm really trying to find is the magnitude of that vector, because it turns out that the rock is hitting the ground at an angle, right? And the magnitude of the velocity vector is just the speed. Okay, so I don't need to make this negative then, do I? I could, because I'm going to square it anyway, but I don't need to. So then I've got v sub x, that was the cosine one.
Yeah.
So I've got the square root of 22.7
Where did you get
times.
that?
Oh no, 39.9. Well, that's wrong. Where did I get that? 39.9 cosine 75.
Yeah.
I need to put another set of parentheses around that to square it, don't I? Wasn't thinking ahead. See why? So now squared plus that number in parentheses, because it's negative, right? Otherwise it'd be wrong. That number squared is 51.5. Why is it not much faster than the vertical component?
Because horizontally stays the same.
Yeah, and it wasn't very big, was it? The horizontal component wasn't very big. This thing was tilted at a 75-degree angle, so it had a pretty small horizontal component, right? Does that make sense?
Yeah.
Okay.
But that's not the answer, is it?
Yeah, that's the
Oh, it
answer.
is?
Yep, that's it. So now, 51.5 meters per second Should we check these out and make sure we got them right?
Sure.
Might as well. See how we're doing. Isn't it just kind of satisfying to get the green check?
Mm-hmm.
But it's equally frustrating to get the red X.
I'd say more frustrating.
Yeah. 93.8 and 51.5.
Yeah, you're like,
Got it. How about that? Make sense?
Yay.
Okay.